So we are moving on to three variable systems. So how do we solve three variable systems by substitution and elimination? Because we're working with three variables, graphing is not an option anymore. We don't know, we can't physically graph something with three variables because that's three-dimensional. So when we had our two variable systems, there was a couple of different options when it came to the number of solutions that we had. Because we were dealing with two variables, we had two linear equations, so they could cross at one single point to give us one solution. They could have not crossed at all. They could have been parallel lines giving us no solution, or it could have been the same exact line, coincidental lines giving us infinite amount of solutions. Well, now that we're dealing with three variables, those aren't lines anymore. Those are planes. So remember in geometry, three distinct points create a plane. So with three variables, we're dealing with these planes. And so a couple different things can happen. Here's a visual for you guys. So in the first example, we have a red plane, a blue plane, and then a green plane. And those three planes are all intersecting at one single point. I don't know if you can see it, but it's a little white dot there. And so that would represent the solution having one, or the system having one solution. If all three of those planes are intersecting at one point, that is one solution. The second example shows our three planes intersecting at a line. So notice all of them are intersecting on that one line. How many solutions would that be? Well, that would be infinite solutions. Now, I want to talk to you real quick about the difference between infinite solutions and all real numbers. This is a case where all real numbers does not apply, because I could have a number here, 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 wherever, and that's not a part of my solution. So this is not all real numbers. Put an extra L on real there. This is not all real numbers, okay? Infinite solutions doesn't mean all real numbers. In the third picture, you should be pretty easy to see that this would be no solution at all. We're trying to figure out where do all three of our planes intersect, and it's very clear that they don't here, so this is no solution. In the last picture, you're thinking to yourself, oh, well, maybe it's three solutions. But remember, we're talking about a system of three equations with three variables. So our key is that we want all three of them to be intersecting. And in this picture, we don't have all three intersecting at one location or infinite locations. So this is another way of representing no solutions. So again, we could have no solution, we could have one solution, or we could have infinite solutions. So the same type as our two variables, but way different images of what we're dealing with. So, like I said, we can't solve by graphing because we don't know how to graph three-dimensional yet. So we're going to solve this by substitution or elimination. So in the first example, I'm forcing us to use substitution for example A and example B. Example A, we're thinking, hallelujah, praise the Lord, because as we see, one of our variables is already solved for. We already know what Z is equal to. And so if that's the case, then I can now substitute that value in for everywhere I see a Z, and then solve for those other two variables, X and Y. So I'm gonna go ahead and do that, and I'm gonna kind of work my way up. So I'm gonna start with this 2y minus Z, which is 3 equaling 5. And so then I would add my 3 over to get 2y equals 8, and so y is equal to 4. And so now I know my y value. And so because I know my z value and my y value, I can go ahead and plug into the top equation and solve for x. So now I have 3x minus 2y, y is 4, plus 4z, z is 3, equaling 7. I'm going to simplify 3x minus 8 plus 12 equals 7. Excuse me. So this is going to be 3x plus 4 equals 7. So this is going to be 3x equaling 3. So this is going to be x equals 1. And so now I know that x is 1, y is 4, and z is 3. And we can totally leave our answer like this, but we can also write it as x, comma, y, comma, z. Because we know that this is one solution. So it looks like this kind of scenario. It is one exact location. Okay, moving on to part B. So in part B, remember we want to use substitution. So a couple of different ways that we can do this, but I'm just gonna go ahead and jump in with this first equation, and I'm gonna isolate one of my variables. So I'm gonna go ahead and just isolate my y variable. So in doing that, and like I said, it doesn't matter how you start, just kind of depends on how you see the problem. So if I was going to isolate this y variable, I would subtract my 4x and then I would add that z over. So this is going to give me y equals negative 4x plus z plus 2. And so now that I know what y is equal to, I can go ahead and substitute that in to the second equation where there's that just one y. So then that's going to give me 4x plus, what is y equal to? Negative 4x plus z plus 2 plus z equals 2. Okay, I know you may be thinking, man, I wish we could have used elimination here to cancel out those z's. You're absolutely right, but I'm forcing you to use substitution here. So I don't have to distribute anything because it's positive. So I really didn't need those parentheses, but you can keep them if you want. And so we see that these 4x's cancel out. Technically, I would get 2z equaling 0, which means z is going to be 0. So now I know that z is equal to 0. And so because I know that z is equal to 0, I can substitute that in. But when I do that, I notice something here and here. If I substitute in the first one, I get 4x plus y equals 2. And in the second one, I also get 4x plus y equaling 2 if z is 0, right? Minus 0 and plus 0 is just 0. So because of that, I have infinite amount of solutions. Because I also can look at that third equation. If I come down here, 12x plus 3y. If I plug in 0 for z, that would be 0 equaling 6. What happens when I divide all this by 3? I get 4x plus y equaling 2. I get the same three things, the same three equations, which makes it infinite solutions. Okay, infinite solutions. So that's substitution. It says solve one equation for one variable, substitute it into the other two equations. Now you have a 2 by 2, solve that 2 by 2, substitute both variables into one of the originals, and then boom, you get your 3 variables. Okay, so now I'm going to force you to use elimination. Elimination, remember we're going to eliminate a variable in 2 of the equations. This is something different because we have 3 variables. Notice here it says eliminate a variable in 2 equations, and then it says eliminate the same variable in 2 other equations, then solve the resulting 2 by 2 system, substitute back into one of the originals. So this part, this and this, are a little bit different, okay? So what does that look like? Well, maybe we're going to eliminate our z. Okay, let's just say I'll go in the first 2 equations. So here and here, I'm going to eliminate my z. Well, to eliminate my z, I just need to multiply that second one by 2. So all of this needs to be multiplied by 2. So I have 3x plus 4y plus 2z equals 11. And then multiplying by 2, I'd have 4x plus 6y minus 2z equaling 8. And so then I get canceled out. I get 7x plus 10y equaling 19. Okay, now because I eliminated z in the first 2, I have to eliminate z in 2 other equations. It doesn't matter if I would go first and third or second and third. I just obviously need to use the third because I haven't used it yet. So I'm going to go ahead and go with my second and third. Let me change colors. So if a second and third are going together, I'm trying to eliminate the z as well. So I'm going to go ahead and multiply this now by a negative 3. So that's going to give me the 5x plus 5y minus 3z equaling negative 1. And then that'll be a negative 6x minus 9y plus 3z equaling negative 12. Z's cancel out. That's what I want. This is going to give me a negative x minus 4y equaling negative 13. So now I have a 2 by 2 system. Okay, so with my 2 by 2, talking about these two right here, so I'm creating a new system. So I have 7x plus 10y equaling 19, and I have negative x minus 4y equaling negative 13. I am going to go with elimination because with the x variables, because I can just multiply the second by 7, and that will give me, let me make this a little bit smaller. Okay, so that's going to give me negative 7x minus 28y equals negative 13 times 7 would be 91. Let's see, 13 times 7, that would be 21, 7, 91. Good. All right, 91. All right, and then I still have this original 7x plus 10y equaling 19. Cancels out. So now I have a negative 18y equaling a negative 72. Dividing by negative 18, I get y to be 4. So now I know what y is equal to. And so I can plug that y value into one of my 2 by 2s. Okay, and so I can say something like, maybe I'm going to use this negative x. Go negative x minus 4y, which is 4, equals negative 13. So it would be negative x minus 16 equals negative 13. Negative x equals 3. So that means x is negative 3. And so now that I know that x is negative 3 and y is 4, then I can plug back into one of my originals and solve for z. So maybe I'm just going with that first equation. 3x, x is negative 3, plus 4y, y is 4, plus 2z equals 11. So this is negative 9 plus 16 plus 2z equals 11. Combining some like terms and solving, I get 2z to be 4, which means z is equal to 2. Whew. I know, it's kind of a lot. Okay. All right, and so now I give you 2 systems, and I just say solve it using whatever method you would like. And so it's kind of up to you. I'm going to use elimination because I see in the first 2 equations that my negative 6y and positive 6y are going to cancel out. So I'm going to do elimination. Okay, so those would cancel out. Let me go ahead and rewrite 8x minus 6y plus 2z equals negative 20. Negative 3x plus 6y minus 15z equals 51. Cancels out. This is going to be 5x minus 13z equals 31. Okay, and so because I eliminated the y in the first 2, I eliminated the y, I need to eliminate the y in the last equation. So I'm either going to use the first with the third or the second with the third. I'm going to use the first because the first is a negative 6y and the third has a positive y. So that means I need to multiply that third by 6. So that's going to give me 12x plus 6y plus 18z equals 0 with that first of 8x minus 6y plus 2z equals negative 20. Cancel out the y's. This is 20x plus 20z equals negative 20. Okay. Which I can then divide everything by 20 and make my life easy and say x plus z equals negative 1. And so now I can use these two 2x2s, and I will eliminate my x's. And so just because it would be a smaller number. So if I multiply this by a -5, that would be a -5x minus 5z equaling 5, with a 5x minus 13z equaling 31. So that's going to obviously cancel out. That's going to give me a -18z equaling 36, which means z is going to be -2. So now that I know that z is -2, I can plug it in here. And I can get x plus z, which is -2 equals -1, which means x is 1. And now that I know x and I know z, I can plug it back into one of my originals and solve for y. And so let's go with that third one because y is by itself. So 2x, x is 1, plus y plus 3z, z is -2, equals 0. So that's 2 plus y minus 6 equals 0. So that means y minus 4 equals 0, which means y is 4. So elimination, you have to eliminate the same variable and then create a 2x2. All right, and so then coming over here, I kind of noticed something right from the get-go with that x, y, z all by itself and then a 5x, 5y, 5z. So I could easily do elimination because I can multiply the first one all by a -5. And let's see what happens. Let's go pink. All of this could get multiplied by -5, and then I would have -5x minus 5y minus 5z equals a -10, with my 5x plus 5y plus 5z equaling 3. Cancel out, cancel out, cancel out. 0 equals, 0 equals, what would that be? Sorry, I just dozed off. 0 equals -7, which is not true. So this is a no solution. The false statement. Put that false statement. False statement. So, no solution. All right, and then we just have 2 word problems. So remember, we're setting up our 3x3. All right, it says a photo album has 80 pictures, each of which is either a square, a rectangle, or a circle. There are 12 times as many rectangles as circles. There are 10 more squares than circles. How many of each type of picture is in the photo album? So remember, we want to make sure that we're defining our variables. And so in this case, our 3 variables are going to be the number of square pictures, the number of rectangular pictures, and then the number of circular pictures. So I'm going to use S, R, and C. And so that's going to be number of squares, pictures, number of rectangular pictures, number of circular pictures. Oops, circle. Okay. So I know that my photo album has 80 pictures. Well, then that means that the number of square plus the number of rectangular plus the number of circular has to equal 80. So I already have one equation. Now I'm going to read on and create my other 2 equations. It says there are 12 times as many rectangles as circles. So the number of rectangles is equal to 12 times the number of circles. All right, there's my second equation. And then lastly, it says there are 10 more squares than circles. So the number of the number of squares is equal to the number of circles plus 10. 10 more squares than circles. So number of circles plus 10 is equal to the number of squares. Notice not every single equation has to have all 3 variables. I have 3 variables and I have 3 equations. That's it. That's all I'm concerned with. now that I have my system, so this is my system, now I can solve it. Really, really easy to use substitution here because R is already isolated and S is already isolated. So then I'll get everything in terms of C, solve for C, and then plug it back in to get that S and that R. So let me change colors. I'll go with the darker green. So in doing that substitution, I'm going to substitute into this first equation. So S, that's C plus 10 plus R. R is 12C plus C equals 80. So let's combine like terms. I have 1C, 12C, 1C. So that's 14C plus 10 equals 80. So that's 14C equals 70. So that means C is equal to 5. So that means there are 5 circular pictures. And so if I know that C is 5, I know that R is equal to 12 times 5, which is 60. So R is equal to 60. And then because I know, again, that C is 5, then I could plug it in here and get S is equal to 5 plus 10, which means that there are 15 square pictures. And then I just want to double check, is 5 plus 15 plus 60 equal to 80? And it is. So that means there are 5 circular pictures, 15 square pictures, and 60 rectangular pictures. And that is what I want as my answers, is how many of each type of picture is there? 60 rectangular, 15 square, 5 circular. All right, and then the last one says solve for the measures of A, B, and C. And so little throwback to geometry, we have a triangle. We do not know that this is a right triangle. This is something that you should know from geometry. Even though it looks like a right triangle, we don't know that it is. There's no notation. There's nothing in the problem that tells us that. All we know is that it's a triangle. And so what do we know about the 3 angles of a triangle? They add up to 180 degrees. So I can go ahead and put in that the measurement of A plus the measurement of B plus the measurement of C, has to equal 180 degrees. So obviously A, B, and C are my variables, and they're representing the degree or the measurement of each angle. And then this picture tells us the other 2 equations. It tells us that angle B is equal to 5A minus C, and it tells us that angle C is equal to A plus B. Okay, so then I can plug those values in using substitution, just like I did with my photo album problem. A plus B. B is actually 5A minus C plus C, which is actually A plus B. Now, I can do another substitution here because I know that C is actually A plus B. So now I have A plus 5A minus A plus B plus A plus B equals 180. So that would be A plus 5A minus B plus A plus B equals 180. So it's going to be 6A equals 180, right? Cancel out, cancel out, cancel out, cancel out. So 6A equals 180. So A is equal to 30. And so if I know that A is 30, I can plug back in here. Oh, no, hold on. I can plug back in. If A is 30, then I can get angle B. Yeah, B is 5A minus C, and then C is A plus B. So B is equal to 5 times A minus C. C is equal to 30 plus B. So I can take that, substitute it here. So B is equal to 150 minus 30 plus B, which is 150 minus 30 minus B equals B. So that's going to be 2B equals 120, which means B is equal to 60. And then if I know that A is 30 and B is 60, then I think it's very clear what C is equal to. Plugging it back in, 30 plus 60 plus C is equal to 180, or just A plus B is equal to C. So C has to be 90 degrees. So it is a right triangle, but we didn't know that from the beginning. Okay, we could not assume that. We had to mathematically solve for that. So that is a 30, 60, 90 triangle. Okay, that's it.